Example 6, I gave you a short video to watch that's in Google Classroom if you want to watch that video on unit vectors. So this one says find a unit vector in the direction of the given vector. We're supposed to verify our answer of the unit vector and give your answer in component form and standard unit vector form. So you see that there's a lot of vocabulary in this question. All right, so we're going to start with a unit vector. So in order to find the unit vector is we take the vector and we divide it by its magnitude. This will give us the unit vector, which will have a magnitude of 1. Think of unit price, 1. So looking at find the magnitude of this vector, the first thing I like to do is change it into component form. It's just easier for me to read. So the component form of that same vector is 2, -4. All right, so in order to find the magnitude, we're simply using the Pythagorean theorem. The 2 is your A, so you have 2 squared plus the -4 is your B, -4 squared, and then you take the square root of that, and it's going to give you the magnitude of your vector. So the magnitude of this vector ends up being the square root of 20. If you take out the perfect square, then you get 2√5. So 2√5. Again, the notation for magnitude is the double lines. So you would do the double lines, and that's the magnitude of vector V. Just a reminder, that's the length of the vector. Now what we're going to do is we're going to divide the original vector by its magnitude. So this is very simple. You just take the original vector, which is 2, -4, and you divide the horizontal component by 2√5, and you divide the vertical component by 2√5. All right, you're going to simplify that so you can see that the 2's are going to cancel here. That's going to give you 1/√5. That'll give you √5/5. When you rationalize, √5/5. On this one, you can say 2 goes into -4, -2 times. And again, we're going to rationalize again, multiply the top and bottom by √5, and you're going to get -2√5/5. This is the unit vector in component form. It did ask us to write the unit vector in standard unit vector form. All that means is we're just going to use i's and j's. So you've got the square root of 5/5i. Subtract 2√5/5j. And that is the unit vector in standard unit form. Okay, so how do you verify if it's a unit vector? Oh, Kelly, what do you think? Travis? Allie? Anthony? I don't know. Someone answer me. So I hope that one of you answered that if I were to find the magnitude of the standard unit vector, and that magnitude is 1, then I will have verified that it's a unit vector. So we're going to go ahead and take the magnitude of vector V. That's going to equal the square root of, and you would do the square root of 5/5 squared plus negative square root of 5/5 squared. The square root of 5 squared is simply 5, and then the denominator, 5 squared, is 25. Oh, I forgot the 2 here. Put the 2 in there. All right, and then -2 squared is 4, and the square root of 5 squared is 5, and I divide that by 5 squared, which is 25. You can see where we're going with this. This is going to give me the square root of 1, which is equal to 1. So I just proved that this vector is a unit vector. In example 7, I'm going to show you a different way to express a vector. So if you look at vector v is negative 2i plus 6j. In component form, that's negative 2 is the horizontal and 6 is the vertical. And someone is working in my yard right now, so you might hear noise. All right, so we're going to graph it. Negative 2 up 6. So here is this vector. And we're going to describe this vector, instead of looking at the horizontal component and the vertical component, we're going to express this vector in terms of its directional angle, which is theta. So we're looking at this angle here. And then its magnitude, which is what's the length that we went to get to the end of that vector. So finding the magnitude is pretty easy. It's the same thing that we did before, is we're going to form a right triangle, and this side of the triangle is 2, and this side of the triangle is 6, and so all we have to do then is just figure out the length of the hypotenuse, which is Pythagorean theorem. So you've got 6 squared plus 2 squared. This is going to give us the square root of 40. When we take out the perfect square, we get 2 root 10. So that was really easy, just to figure out the magnitude. The next thing we need to do is find the directional angle. Now the directional angle is going to be theta, but before I find theta, I'm going to use this right triangle, and I'm going to find theta prime. And so we're going to just go ahead and use tangent. What do you think? Say yes, let's use tangent. All right, so tangent is going to be the tangent of theta prime is going to be opposite, which is 6, over adjacent, which is 2. So we are looking at theta is going to equal the inverse tan of 3. So now what you're going to do is put that in your calculator. You're going to make sure that you're in degrees, and theta prime is going to equal 71.565 degrees. Now what you have to do to be really careful on this problem is you need to notice that theta is this angle, and that is not 71 degrees because we are in the second quadrant. So you always want to graph your vector to know which quadrant you're in. And I use tangent for the reference angle. And so now I can figure out what theta is. All I have to do is take 180 degrees and subtract the 71.565 degrees. And theta is actually going to be 108 if you round 3 places, 435 degrees. So now what we're going to do is rewrite this vector. Instead of it in component form, which is negative 2, 6, we're going to rewrite it as a resolving vector. That is going to look like, now you can factor the magnitude of u out if you want. I'm going to go ahead and write it in the vector. So we're going to have 2 root 10, which is the magnitude of the vector. And then we've got the cosine of the angle, which is 108.435 degrees. That's the horizontal component now. And the vertical component is going to be 2 root 10 sine of 108.435